Okay, so the pump side is rebuilt, and you know, the pump cannot develop enough pressure to unseat the metering needle to get it to pop off. The pressure that this pump develops is very low, and so that's why I had to disable this part. If this were mounted on the engine, the low pressure when the engine is inhaling the air, the low pressure acts on the metering diaphragm, and the metering diaphragm will push on the lever and the lever will unseat the needle, and then the fuel pressure that's behind the needle supplied by the pump will allow the fuel to flow into the metering chamber. And I want to also mention another misconception some people have is the frequency and movement of the two different diaphragms. The pump diaphragm is going to be pulsing, and the lay flat valves are going to be pulsing at the same frequency the engine is running. If this thing's going to run 9 or 10,000 RPM, at full wide open throttle, that's what this pump diaphragm is going to be pulsing back and forth. The metering diaphragm is different. Okay, the metering diaphragm, when there is a very low intake of air, the metering diaphragm will just move just enough to unseat the needle and allow fuel to flow into the metering chamber. And the greater and greater demand of air when the throttle is opening, greater and greater and greater degree, the metering diaphragm will act more, but it will not be moving at a frequency. It will reach a mean level to match the demand, the fuel demand of the engine. And when you go back to idle, then the diaphragm will relax and go to a different level. So these diaphragms are not moving 9,000 times, 10,000 times per minute. It moves, it stays, it moves depending on the throttle position and the demand of the engine has for fuel. Another thing I want to mention is the kits. I only use OEM, Zama or Walbro or Tillotson kits, and I've found that the cheap aftermarket kits, especially on the pump side, the pump gasket, for example, the diaphragms and the gaskets and so forth on the aftermarket kits, the quality is terrible, and the gasket material is like a sponge, and even the sharpest crush rib. Let's see, I can bring this in for close up. If you can see the crush rib indentations all the way around the chambers, those crush ribs that are cast into the pump cover are designed to prevent fuel and air from migrating sideways through the gasket material, the fibers of the gasket material. And the cheap ones are made out of like sponge material, and they leak like a sieve. That's the gaskets. As far as the diaphragm goes, one area on a metering diaphragm that is absolutely critical is this raised bubble donut that surrounds the umbrella frame. That's called a convolution, and that convolution is what allows the diaphragm to move. And the poor quality aftermarket kits, this convolution is poorly formed. Got a lot of wrinkles in them, and sometimes the umbrella frame is not flat. You always need to check these for flatness. This metal plate has got to be 100% flat as a plate. If it's potato chipped or bent in any way, it's not going to work. So, stick with your OEM high quality kits and you're not going to run into problems. Now, in rebuilding the metering side, the next thing I want to do is talk about the high-speed check nozzle. Earlier, I showed you that there was nothing more than a screen in here. And you're probably wondering, well, how is a screen going to prevent air from bleeding backwards into the metering chamber? How is that a check valve? It's a screen. Well, this is the new screen, and there's what's called capillary action. If this screen is wet with fuel, very, very, very low pressure air is not going to go through it. Let's see here. Okay. Let's see here. So if that screen is wet with fuel, low pressure air will not pass through it, and that's called capillary action. And this is the type of a check valve that is on all of the early Tillotson carburetors. The later, newer ones, they use a brass capsule that's pressed into the metering chamber floor, and it protrudes into the venturi. And those more modern check valves use like either a nylon ball or like a Teflon wafer disc. And when the fuel is allowed to go one way, but when fuel stops flowing, that ball or that wafer disc settle back down into a seat, and no air can go backwards. And a symptom of a defective check valve, a high-speed check valve in any of these diaphragm carburetors, would be if you start up and you're running and you're high speed, wide open throttle, and then you let the throttle go and you come back down to idle, and it idles for about 30 seconds and then it leans out and dies. That is where you need to address your check valve. And some carburetors, the check valve is not serviceable. So if you spend time overhauling a carburetor that has a bad high-speed check valve and it doesn't work, you've got to scrap the whole carburetor and you've wasted that overhaul, and you got to replace the carburetor. Most of the high-end carburetors, the check valves are serviceable. So obviously that was an issue with this one. So I'm going to be dropping this little brand new screen in there, and it's tiny. It's going to be tough. Okay, so let's have a look here. No flashlight. Okay, so I hope you can see that. The screen is now at the bottom of the high-speed nozzle and the retainer is holding it in. So the next step is to cover it up. We're going to cover it up with a brand new Welsh plug. And the domed side of the plug has to be up. And then what you want to do is take a punch that's the same size as the plug or slightly larger, and flatten the plug out. Let's get that. Okay, so now the high-speed nozzle is plugged off again. And the next step is to put the original spring in. So they do not give you a replacement spring in the repair kit. And we are going to use a new lever and a new needle. And this is the same thing as the gaskets and the diaphragms. You want the needle in the seat wet. And then we are ready for a pressure test. Hopefully it will pass. Okay, that's looking really good. That's a pretty high pressure, higher than is necessary. That's 1 bar. It's about 15 pounds. And there are no bubbles, no bubbles at all. I'll fill that up. Yep, so that's 1 bar. The needle is not budging. There are no bubbles coming from the inlet needle. The next thing I want to do is make sure that the metering lever is not too high or not too low. The metering lever is supposed to be flush with the floor of the metering chamber, not higher and not recessed down low. So you just need like a little straight edge. Doesn't have to be anything fancy. Let's see what we got here. Should have had my straight edge ready. I'm going to pause and come back with a straight edge. Okay, I'm back with a straight edge. Okay, it is a little bit high, just a little bit high. I'm going to demonstrate what just happened here. Okay, so if I put the straight edge down on top of the metering lever, if you watch the gauge, so that would indicate that it's high. So I'm going to have to do a little bit of bending. And then what we can do is push down on the needle, hold the needle down, and then push down on the lever, and the lever will bend. It's not going to need a lot. And then retest. And we want not an immediate. Okay, that's better. That's better. When I push this down flush, it just barely, the needle drops very slowly to zero. That means that the level of the metering lever is just barely higher than the floor of the metering chamber. And that's very accurate. That's an accurate way to adjust the metering lever. You can use your pressure gauge and a straight edge to do that. So the next step, I guess we can put the needles back in. And these needles, you can't mix these up. They are different threads, so you can't put one in the wrong hole. This is the low speed needle. And the preset for this is, I think, between 3/4 and 1 turn from lightly seated. Okay, if you force the needle into the seat, you will damage the needle and the carburetor body. Just lightly seat it, back out 3/4 to 1 turn. Go 1 turn. Same thing with the high-speed needle. Go all the way until it's lightly seated. There it is. And back out 1 turn. And before I install the metering gasket and the metering diaphragm and cover, I just want to point out a few things about carburetor overhaul. Let's see. So this carburetor has an independent low-speed circuit which picks up from a hole right there, and then is adjusted by the low-speed needle, and the adjusted amount of fuel is then routed into what's under this Welsh plug, and it comes out into these little idle ports here in the throttle bore. The high-speed circuit picks up its fuel from this hole, and then it is adjusted by the high-speed needle, and the adjusted amount of fuel is then fed into the high-speed nozzle and then into the venturi of the carburetor. Now you're thinking, okay, well, every carburetor has two circuits. Just like electrical appliances have electrical circuits, and forklifts and tractors have hydraulic circuits that have valves and motors and hoses. Carburetors have fuel circuits, and I've just shown you where the idle circuit is and the high-speed circuit. But this carburetor has one more circuit in it that is not used on every carburetor. It's only used, on certain applications, and that is the governor. This carburetor has a governor on it, and in the old days they didn't have any way to, there weren't limiter caps to prevent leaning out. There weren't electronic governors built into the ignition coils to limit the revs that the motor would reach. This is a small bore, long stroke, high torque chainsaw, this 050, and it can only run about 10 grand, 10.5, and if you were to lean out the high speed needle and get it to scream 11,000, 12,000 RPM, it could blow up. It'll seize and blow up. So, Stihl, what they asked for Tillotson for was, one of the governors, and this is like a dump valve, and it's the third circuit in this carburetor, and it picks up its fuel from right there. There's a hole right there, and inside of this governor valve, there's a spring and a ball, and the spring is calibrated. And once this engine reaches about 11,000 RPM, that ball in the spring, the frequency of it starts releasing the ball off of the seat, and then fuel will go right by the governor valve and get dumped into. There's a hole in here, and it'll enrich the mixture and slow the engine down and save it from blowing up. And so that is the third circuit in the carburetor. So I wanted to show you that before I put the metering side back together. And once I put the metering side back together, the carburetor overhaul is pretty much complete. But I did run into a problem. The throttle shaft, as I mentioned, the original throttle shaft, I think the customer may have dropped the carburetor, and that's what bent the throttle shaft. The throttle shaft is bent, and it was worn out anyway. Once the chrome is wearing through and you're into the brass, that's bad. Dirty air can be inhaled through the extra sloppy bore and be swallowed by the engine, and the dirt will wear out the piston rings and the cylinder and the piston. So there were other issues besides just this loose lever, the riveting onto the shaft from the lever to the shaft. But another problem I ran into was the butterfly. The butterfly, somebody's worked on this carburetor, and the butterfly was rotated around 180 degrees out of position. And I could tell when I held the throttle, the carburetor up to the light, I saw a lot of light passing around the edges of the butterfly. And the butterfly has beveled edges. This is not a round valve. It's slightly oval, and the edges are bevel cut. And if you put it in backwards, it will not seal the throttle bore properly. So I had to play around with that throttle valve and spin. It was spun around the wrong way. Now it's in there correctly, and it comes to a full seat. So I thought I was going to have to order this throttle shutter. And Stihl does still make this throttle shutter, and it's not expensive. And I thought I was going to have to delay the job and order a $3 throttle shutter. But as it turns out, it was somebody just put it in backwards, and now it's in there the right way, and it seals much better. So you can just watch me just put the metering side back on. And it's important to again check the umbrella frame for bending. It's got to be flat as a plate, and you've got to hook. This is a captive style metering diaphragm. The captive ones are more common to the larger cube carburetors. When you get into a mini cube carburetor, most of those do not have captive metering levers, forked metering levers captive to the diaphragm. They just have a little lever that touches a rivet on the diaphragm. Tillotson was the pioneer in developing these. In the 1940s, Tillotson was the first one to really come out with an all-position pressure differential carburetor, and that was like the HL style carburetor. It had mounting flanges for the air filter and the intake. And in the 60s, chainsaws started to miniaturize, and so Tillotson was the first one to come out with a cube carburetor, and that's an HS carburetor. And then later, as chainsaws continued to miniaturize in the 70s, they came out with a mini cube carburetor. That was an HU. And then Walbro started in the 70s, and Zama also followed them. And so there's a lot going on there as far as technological advancements. Tillotson was sort of at the cutting edge of that. Stihl became Zama's largest customer, and they were buying a lot of their product. And eventually, since Stihl likes to control and manufacture in-house as much as possible, they ended up buying a controlling interest in Zama. And so now they kind of shut out Echo, and Echo had to go to China and have carburetors made in China. They can't get Zama carburetors like they used to. And also a lot of the repair kits and carburetors themselves, you used to be able to buy all the RB Zama repair kits from a Zama distributor. Well, those Stihl put a stop to that, and they shut that off. And so now, instead of buying an RB kit, you have to order a Stihl part number from Stihl, and the kits that Stihl supplies, they're not a full RB kit. They only have the gaskets and the diaphragms, and they're about $20. And in the old days, you could get an RB kit from Zama for a Stihl product for about $8. But that's what happens when the 800-pound gorilla in the room, buys out the manufacturer. So Zama is probably more than 50% owned by Stihl. So that now is a completed carburetor overhaul. And you know, I could throw a kit into one of these carburetors in 5 minutes. But I'm trying to explain the reasons and some theory. Another part of theory that's important to know is these carburetors on a gasoline engine, they're supposed to mix about 14.5 parts air to 1 part gasoline. And but that's by weight. Now, if you can imagine, this is a 12-ounce can, but if this was a 16-ounce can, a 1-pound can, and this were full of gasoline and it weighed 16 ounces, if you just took 14.5 cans, 16-ounce cans full of air, what's inside those 16-ounce cans weighs 0. It's what you would have to do is you would have to compress all the air in this room, you know, probably over 1,000 psi. There is a you know, some formulas to figure out, you know, but this is not a physics lesson. If you compress the air to the point where it would fit into a 16-ounce can, and you compressed it enough, it would weigh 16 ounces. And so if you had 14.5 cans of air that were compressed, and each of those cans weighed, I guess 14 of them would weigh 16 ounces, and the 15th can would weigh 8 ounces. And it's by weight. So a carburetor is mixing the 2-cycle fuel at that ratio. And if the ratio is off, you are adjusting it with your adjustment needles, and to get that magic sweet spot of 14.5 to 1. Now, for you know, a diesel engine, it's different. For you know, an alcohol engine, it's different. For every fuel, it's different. But for gasoline, it's about 14.5 to 1, maybe 15 to 1. And so that's what a carburetor is doing. It's mixing air and fuel. So it's always important to keep that in mind, because then you know what you're doing with these adjustment needles. You're trying to hit that sweet spot, and that's where the engine is going to run the best and produce the most power. Mistake a lot of people make is, you know, they will over lean the high speed, and the engine will run at a higher RPM, but it's not under any load. When you bury that bar and chain into a big piece of wood, and it's demanding the maximum amount of power, there's not enough fuel. You're gonna have to back that screw back out to hit that sweet spot and get the maximum amount of power out of it. And so that's what your adjustment needles are for. So I don't want to make the video too long to learn everything you need to know about carburation. You're going to have to watch numerous videos of mine. I'm going to be, you know, adding more. Carburetor overhauls are one of the most frequently needed things on, you know, power equipment, chainsaws, blowers, trimmers, and whatnot. And a lot of the principles apply. You know, they're just different styles of carburetors. There's slide valve, rotary valve. Rotary valve carburetors don't have a high-speed check nozzle. They operate a little differently. But I'm going to put this carburetor, you know, back on the engine. You don't need to see the nuts and bolts. And I'm probably going to wash the air cleaner base and just do a few little minor other things, and I'm going to try to put some fuel in it and try to start it and run it, and we'll see what happens. So I'm going to pause for now.